Essential to discussing circles are talking about angles and arc measures in circles. And so, first off, we want to talk about central angles. Central angles are called central angles because they have a vertex, B, at the center. So our angle here, ABC, has a measure of 60 degrees. Now, it's called a central angle. The arc here, AC, which I can say measure of AC, and I put the little arc symbol over top of it, it also measures 60. Because if you remember, all the way around a circle is 360 degrees. And so whether you go all the way around in the angle or you go all the way around in the circle, you get 360 degrees. Now, right now we have 60 degrees because we said AC, but what if we wanted to go all the way around? Well, AC is just the minor arc. Anything less than 180 is a minor arc. And so if we wanted to go the long way around, we would have to use 3 letters to say ADC. And so measure of arc ADC is 300 because all the way around would be 360. We've already taken 60, so 360 minus 60 is 300. And so the major arc is anything over 180. And so anytime you see those 3 letters, typically it's signifying a major arc. Sometimes it's just letting you know which way to go with it. But you have to use 3 letters if you want to talk about major arc. Otherwise, if you just say AC, there's no way that you're talking about the long way around. Have to use that 3rd letter. If we go halfway around, it's called a semicircle, and it's exactly 180. And so less than 180, bigger than 180, we have minor arcs, major arcs. And just DC would be 180. And how do I know it's exactly 180? You have to be careful because you don't want to assume that DC is the diameter, but we've been told, I wrote down that it was the diameter. Because sometimes things look like they're diameters or that they're going straight across, and maybe there was a bend. Not much of a bend, but what if it was 179 and you can't trust the picture, so you want to be given that it's a diameter. So what we can do is we can add different arc measures together as well and come up with missing things. And so I've got this big circle for you here. Marked the central angles. And so I want to find the measure of arc AD. So A to D. Well, that's made up of the 50 degree central angle and the 35 degree central angle. And so what we're going to do is do 50 plus 35 and get 85 degrees for our arc measure, because the arc measure is the same as your central angle. Measure of arc EB. Well, EB goes from here all the way to there. Now, this is 50 plus 130. And so that's 180. And so that is a semicircle. Sorry, this was a minor arc. This is a semicircle. And how did I know which way to go around? Well, it ultimately didn't matter because it was a semicircle, but you'd always want to go around the shortest route. And so if you add together those and got 180 or 182, you went the wrong way. But now that I know that that was 180, I can find arc DC, because if EB this way had to be 180, this way also has to be 180. So I could say 35 plus something plus 40 equals 180. And so if you subtract this over there, subtract over the 40, subtract over the 35, or these add together make 75. So 180 minus 75 makes 105 degrees. And so that's the measure of arc DC. You can also find the measure of major arcs in there as well by just adding and subtracting and things like that from 360. Now finally, we can have congruent angles and congruent arcs. So say we had 2 angles, 2 central angles that were marked congruent. That implies that these arcs are congruent as well. Makes a lot of sense. If this angle's 50 and this angle's 50, then the arc will be 50 and the arc will be 50. Now, if this angle was 120, then this arc would be 120 and this arc would be 120. But we don't call these congruent because the radii are different lengths. And so you notice this one's much smaller than this one because it's in a smaller circle. And so we don't call those two arcs congruent. So there you have it. Whatever the central angle is, the arc is equal to it. And that's the moral of today. Central angles, minor arcs, major arcs, semicircles halfway around.